Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how do you figure out the amount of a certain metal in an alloy that reacts to make some hydrogen gas. So let's get into this. So in this sort of problem, like you're given a 0.155 grams, or you're given a sample of an alloy, just generally speaking, and you have a couple of metals mixed together, or maybe you have a mixture of two elements mixed together, and they both react to form a particular product. And so you're then asked, well, how much of a certain element or how much of a particular element or a particular metal is made up of in this particular alloy. And so how do you go about solving this sort of problem? Well, the way you go about it is to use a system of equations. So you're going to need to have multiple equations because you're going to have multiple unknowns. So let's get into this. So in this particular problem, you have a 0.155 gram sample of an aluminum magnesium alloy, and you're told that that alloy reacts with an excess amount of HCl to produce 0.0163 grams of hydrogen. And then they're asking, what is the percent of magnesium in the alloy? So how do you go about doing this? Well, first thing we know is that we know that both aluminum and magnesium are mixed together in the alloy, and both of them are reacting with the HCl to create the same product, which is H2 gas. So if I know that the alloy is made up of aluminum and magnesium only, and I know the mass, well, then I know both of those metals added together must be the total mass that I'm given. So here I'm told that this is going to be the total mass of the aluminum and the magnesium in my alloy for my sample. So since the total sample is 0.55 grams, that means that the aluminum plus the magnesium in that sample adds up to adds up to the total mass. Okay, so both of those metals are going to react to form hydrogen gas. So I'm going to need the balanced equations for both of those. Okay, so I know aluminum is going to react with HCl. So I'm going to write down aluminum solid is going to react with HCl aqueous, and that's going to produce a couple of products. So you have to write out the balanced equation yourself. However, if you know the reactants, you can figure out what type of reaction this is. So if you know this is an element, right? This is a compound. Anytime you're given an element and a compound, that's a dead giveaway that you have a single replacement reaction. So in this case, the aluminum is going to replace the hydrogen. Think about positive ions replacing positive ions. Hydrogen is going to break off. This is an acid. It's going to dissociate or ionize in water. So the H is going to have an H plus. Aluminum, when it combines to form a product, is going to have a positive 3 charge. So what's going to happen is the aluminum is going to kick off the hydrogen, form an ionic compound with chlorine, and then we'll have hydrogen gas left over. So aluminum is going to have a 3 plus charge. The chloride ion is going to have a -1 charge. So I'm going to need 3 chloride ions to balance the charge of the aluminum. So one of my products is going to be AlCl3 aqueous. And then the hydrogen is going to be by itself. So remember, hydrogen is one of the diatomic elements. If you don't remember what the 7 diatomic elements are, always remember horses need oats for clear brown eyes. Horses H, needs N, oats O, yeah, 4, fluorine, clear brown eyes, chlorine, bromine, iodine. Horses need oats for clear brown eyes. That's a good mnemonic device to remember the 7 diatomic elements. Okay, so now that I have the products and reactants and the right formulas, I have to balance the equation. So I have one aluminum, one aluminum. Always balance the metals first, right? So when you're balancing chemical equations, metals before nonmetals, that's a general rule, right? So I'm going to balance metals before I balance nonmetals. Then, once the metals are balanced, I'm going to balance the nonmetals. When I'm balancing the nonmetals, I balance everything first except for hydrogen and oxygen. One of the rules, though, is if I have an element that's by itself, I'm going to balance that first. I'm going to balance it last. I'm going to balance everything else first, right? And then whatever that is that I have by itself, I'll balance that after I balance everything else first. But a general rule of thumb is for nonmetals, you're going to balance everything except for hydrogen and oxygen. And then when you have those two left, you balance the oxygen last, normally, not always. So in this case, you can see that we have aluminum and we have hydrogen that they're by themselves. So which one do I balance last? Well, the rule is that I balance metals before nonmetals. So hydrogen I'm going to save for last. So aluminum, I have one here. Aluminum, I have one there. So that's balanced. Next is chlorine. So I have one chlorine here. I have 3 chlorines there. So I'm going to have to put a 3 here. So now I have 3 chlorines. And I have 3 chlorines. Now I have the hydrogen less. Everything's balanced except for hydrogen. I have 3 hydrogens here, but I have 2 here. So how do I get 3 on this side? Well, you can use fractions. So this is why we leave it for last, so that we can easily use a fraction to balance both sides. So I have 3 on this side. I need 3 on this side. So what times 2 gives me 3? 1.5, or 3 halves. So if I put 1.5 here, or 3 halves, now it's balanced. However, I can't keep the fraction, so in order to get rid of the 2, I need to multiply by 2. But I'm going to multiply everything by 2 in order to keep the equation balanced. So this is going to be 1 times 2 is 2. 3 times 2 is 6. 1 times 2 is 2. And then here I have 3 and 3 halves times 2 is 3. Okay, so that's my first balanced equation. So that's for aluminum, but I have magnesium in the alloy, so I got to do the same thing with magnesium. So I have magnesium solid. That is also going to react with HCl aqueous. And in this case, the magnesium is going to kick off the hydrogen, form a magnesium chloride salt or ionic compound, and then the hydrogen will be by itself. So again, a single replacement reaction. So in this case, I'm going to have MgCl2 aqueous plus H2, and this is gas. I forgot to put the gas. Okay, so now that I have my equation, I need to balance it. So metals first, so 1 magnesium, 1 magnesium. I'm going to save hydrogen for last because here I have hydrogen and I have magnesium, but metals come first. So now that the metals are balanced, I'm going to do chlorine. I have 1 here, I have 2 here. So I'm going to need a 2 over here. Now I have hydrogens, so I have 2 hydrogens here, and I have 2 hydrogens there, so this is balanced. Okay, so now that I have 2 balanced equations, now I can go ahead and start solving this problem. Now, I said before that I need equations to solve this. And so I said, well, since my alloy is made up of aluminum and magnesium, then the masses of the aluminum and magnesium must be added together to get the whole mass of the sample. So, which is 0.155 grams. So let's make aluminum. I'm going to call aluminum X, and I'm going to call iron Y. So if the amount of aluminum I have is X and the amount of iron I have is Y, then I know that the X, the amount of aluminum X plus the amount of iron Y must add up to the total amount, which I'm given 0.155 grams. So now I have my first equation. But notice I have two unknowns. So I need a second equation in order to do a system of equations and solve for the one of the unknowns. In this case, we want to find magnesium, which is, oops, I have iron. Why did I say iron? It's magnesium. Sorry for the confusion. Okay, so magnesium is Y, so I'm going to have to solve for Y. But I need another equation. This is where these balanced equations are going to come in, because I know that both the aluminum and the magnesium in my alloy react with HCl to form hydrogen gas. So I know that a certain amount of hydrogen gas is produced from the aluminum, and the other part of the gas is going to be formed from the magnesium. Both the amounts of gas, hydrogen gas formed from aluminum and magnesium added together must equal the mass, the total mass of the hydrogen that I'm given. So all I need to do is find the amounts of hydrogen that came from both the aluminum and the magnesium, and this is where stoichiometry is going to be important. So I need to convert the amount of aluminum I have to hydrogen gas. So anytime you are asked to produce or convert from one substance to the other and you have a balanced equation, that you're going to use stoichiometry. And so there's three stages to a stoichiometry problem. The first stage is to convert the units you're given to moles. Why? Because the only way that you can convert between one substance and another substance is to use the mole ratio. So you need moles for that. So let us begin with aluminum. So I'm going to begin with aluminum here. So I have X grams of aluminum. I'm going to convert X grams of aluminum into a certain amount of hydrogen gas in terms of X. I want to find grams of hydrogen gas in terms of X. So I'm just going to do a stoichiometry problem. So I'm just going to do my stoichiometry like I normally do. So now I got to convert grams to moles, right? So I'm going to have to use the molar mass of aluminum. And when I look that up, I get 26.98. So 26.98 grams of aluminum on the bottom and 1 mole of aluminum on top. So grams are going to cancel out grams of aluminum. Now I have moles of aluminum. Now I'm done with the first part. The second part is to use the mole ratio to go from moles of aluminum to moles of hydrogen gas. And so I'm going to need to use the mole ratio from my balanced equation. So I know that 2 moles of aluminum is going to produce 3 moles of hydrogen gas. So I'm going to put 2 moles of aluminum on the bottom and 3 moles of H2 on the top. So now moles of aluminum cancel out, and now I have moles of hydrogen gas. But I don't want moles of hydrogen gas, I want grams, because they're giving me the amount of hydrogen gas in grams. So I'm done with the second part of the stoichiometry problem. The third part, once you've converted from moles of one thing to moles of the desired thing, then you need to convert the moles to the desired unit that they want. In this case, grams. So again, I'm going to have to use molar mass to convert moles to grams. And so on the bottom, I'm going to put 1 mole of H2, and on the top, I'm going to put 2.018 grams of H2 on top. So moles of H2 cancel out. And so now all I need to do is just multiply everything together. I'm going to multiply 3 times 2.018, divide by 26.98, divide by 2, and so on. And so I'm going to get my amount of hydrogen produced from aluminum in terms of X, because notice I have X, I have to multiply that as well. And when I do that, I get 0.11207. So this is going to give me 0.1121. We'll round it to 21. So 0.1121, and this is grams. Oh, I forgot the X. We need to have that multiplied by X because we have X there. So this is going to be multiplied by X grams of hydrogen. Oops. Let me bring this down here. So this is going to be equal to 0.11, what did I say? 21. 21 times X grams of hydrogen. Now I do the exact same thing with magnesium. Oops. Sorry about that. Okay, so magnesium is next. So in this case, it's Y. So I'm going to have Y grams of magnesium over 1. And I'm going to do the same thing. I'm going to convert the grams of magnesium into grams of hydrogen gas using the same steps. So the first step is to convert magnesium grams to moles. So I'm going to need the molar mass of magnesium, which is 24.31. So 24.31 grams of magnesium on the bottom, 1 mole of magnesium on top. So grams of magnesium cancel out. Next is the mole ratio. So I'm going to use the mole ratio between magnesium and hydrogen in my equation here. So 1 mole of magnesium is going to give me 1 mole of hydrogen. So it's a 1-to-1. So 1 mole of magnesium on the bottom, 1 mole of H2 on top. So moles of magnesium cancel out. Now that I have moles of hydrogen, I'm going to use the molar mass. So I'm going to do this step again. So again, I have 1 mole of H2 on the bottom and 2.018 grams of hydrogen on top. Moles of hydrogen cancel out. Now I have grams of hydrogen, so I'm done. All I need to do is multiply across the top, divide by the bottom, and I got my amount of hydrogen produced from magnesium in terms of Y. So when I do that, I get 0.08295. 0.08295. So that's going to be equal to 0.08295. Let me double check. 8295, yes. And that's going to be multiplied by Y, and that's going to be grams of H2. So now I have the amount of hydrogen produced from magnesium in terms of Y and the amount of grams of hydrogen produced from the aluminum in terms of X. So now I know that both of these amounts of hydrogen add up to 0.0163. So there's my other equation. So I have this, so 0.1211, 1121 times X plus 0.08295 times Y is equal to 0.0163. 0.0163. So there's my second equation. So I have my first equation here, and I have my second equation here. So now all I need to do is start solving for magnesium because they want the percent magnesium. So I need to know the number of grams of magnesium in my sample. So magnesium is Y, so I want to solve for Y, which means I'm going to have to substitute X. So here, I'm going to have to say that I'm going to have to solve this for X. X is going to be equal to this minus Y. So 0.155 grams minus Y. So now that I have this, I'm going to substitute that in for X. So then I get 0.1121 times 0.155 minus Y plus this, plus 0.08295 Y. And again, that's equal to 0.0163. Okay, so now that I have substituted, now I can multiply this out through these two. So I'm going to multiply 0.1121 times 0.155, and then multiply this by negative Y. And when I do that, I get 0.011737. 0.01737. So I'm going to get 0.01737 minus 0.1121Y plus 0.08295Y equal to 0.0163. Okay, so now that I have this Y and this Y, I'm going to add these two like terms together so that I have one term with Y. So I'm going to take this and subtract this. I'm going to get a negative here. And when I do that, I get negative 0.02915. So I'm going to have 0.01737 minus, what was that? 2915. So 0.02915 times Y is equal to 0.0163. Okay, so here now I have this y term, I added these two together and I got negative 0.02915y. And so next, I'm going to add these like terms together. So I'm going to have to subtract this from both sides. So I'm going to subtract 0.01737 over here and also minus 0.01737. So then these are going to cancel out. And then I'm going to subtract those two here. And when I do that, I get negative 0.00107. I'm going to erase this up here so that way I have more room. So I have here negative 0.02915 y, and this is going to be equal to, what number did I get? 0.00, so negative 0.00107. Okay, yeah. All right, so now the last thing, I'm going to divide by negative 0.02915 both sides so I can get y by itself. So this is going to be divided by negative 0.02915. And so, of course, the negatives are going to cancel out, become positive. And so then when I calculate this out, I get, let's see, 0.03674. So y is equal to 0.03674. Let me just double check that again. 0.03674. Yes, and this is grams. And since y is magnesium, this is grams of magnesium. So this is equal to the mass of magnesium in the original sample. So now I can find the percent magnesium. And how do you find a percent? Really easily. So just to remind you what a percent is, I'll write it over here. A percent is a part, let me write. Percentage is equal to a part divided by a whole multiplied by 100. So percent means out of 100. So the first thing you always do is you get a fractional amount, right? So part divided by whole. And then to make that out of 100, you multiply by 100, okay? So what's my part in this case? Well, the whole is the sample of magnesium and aluminum together. That's my whole. Well, what's the part? The magnesium. So the mass of magnesium is going to go on top. So I'm going to take the mass of magnesium, 0.03674 grams, and I'm going to divide that by the whole. What's my whole? 0.155 grams. So I'm going to divide that by 0.155 grams. And then I'm going to multiply that by 100. And when I do that, I get 24,492. So I'm going to get the percentage, the magnesium, percent magnesium is 24. Let me look at that again. 24.492. Okay, so what about sig figs? So sig figs are going to be 3 sig figs because I have 3 sig figs here. So we want to make this into a 5. So 24.5% magnesium. So that's the amount of magnesium, that's the percent of magnesium in my alloy. So I hope this was helpful. If this was helpful, then please by all means like the video, share the video, hit that like button over here somewhere or over here. Make sure that you support my channel, subscribe to the channel, hit my notification bell. And then when you hit that notification bell, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you need help with, I'm your man. If you have a topic you want me to cover, I would love to do that for you. Thanks for joining me and have a great day.